Hi and welcome to another episode of TX Bench. Yeah, you already may remember this linear amplifier. So we had it in a couple of weeks ago and yeah, we had to fix a buyer's issue. Anyways, now it is not in for another issue, another repair. This time it is a modification. So you may see here there is no band switch, and that is because this amplifier was designed to get connected to a system connector of a radio. I believe this one was originally connected to Icon IC735. I'm not entirely sure, but I believe that is what it was. And so the radio were selecting the band. Now the IC735 is not any longer available, so the operator has a new radio, and he just wanted to keep his linear amplifier as it is still working very good. And so he decided, hey, let us please install a band switch where I can manually do my band setting. So that is what our amplifier is in today for. Yeah, and you're looking here at the back of our Transworld TW-500A. So that is a 500 amplifier, 500 watt amplifier, and it is full transistorized. So and this here is our remote socket, so where the radio was connected to, and so it was no problem to get the right band selected. Well, some of you may wonder, why do we need a band selector? So we need the band selector to switch the right low-pass filter in. So you see here our low-pass filter board, and of course we have here our amplifier, and we need the right low-pass filter for the band where our radio is sending on or transmitting on, right? And therefore we really need to have the right filter. So why do we need the right filter? To keep the harmonics as low as possible, and that we do not have distortion on the air. So therefore it is very important to have a good working low-pass filter set, and therefore you have to choose the right one, and therefore we need our band selector. And that is what we want to install. I mean, basically it is a switch here like this, which will where we will be able to set the right band, so that means the right signal pass to the right filter. I don't know if you can see it but here is a knob. So that is a plastic cover here, and there we can put our selector switch in. So that is already prepared, that, you know, selector switch can be installed, and that is what we are going to do. So basically that is not really a big thing, because we simply need to pick here the wire which is responsible for one of our filter set, and we need to switch it to ground, that the filter set will get switched finally. And therefore something like this is here very easy to use. So we really connect via a wire the connector here with our switch, and then here our middle pin will go to ground, and then I can switch here one low pass filter after the other. So that is really no big deal, very easy. But that is not the complete story. So, I mean, we really need to consider that from the moment where we have installed here our manual switch, there is no guarantee any longer that the right filter will be switched finally, because the operator has to do it. And the question is, if the operator has set for instance, his radio to the 80 meter band, but the filter here, the low pass filter, is still set to, I don't know, 20 meter band. So then, you know, both is not really matching, and that can end up in a bad SWR, which then could mean that you get destroyed, maybe here your amplifier itself or something other. So, you know, if it is not 100% clear that you are able to protect your amplifier itself, then you should not do it. So therefore, we really need to have a SWR bridge, which is permanently observing if there is a high SWR from the final board into our low pass filter board, and of course the reflected power which goes back here to our amplifier. And this SWR shouldn't be that high, because we do not want to jeopardize here our amplifier, and therefore we need an SWR protection, so that if the SWR is going up, I mean over 3-to-1 or even more, then we need a protection circuit which is able to disconnect our triggering, just to really protect here our amplifier, because all these transistors which are here in our amplifier stage are really expensive, and you do not really want to blow your amplifier board just because you have set the wrong band setting. So therefore we have to build an SWR bridge and a protection circuit which is able to see that there is a high SWR, and which is then able to disconnect finally our driver stage, that there is no power which goes out of our amplifier and gets reflected in the wrong low pass filter pass. So that is what we need to do, and that is a project. So I've already built here our reflection bridge or SWR bridge. So basically that is nothing really special. So SWR bridges are known for decades, so nothing special. So we have an input where we send our, in our case, our amplifier board power in, and this will be the output which goes to our low pass filter board. And then we have finally here two pins. One is for the forward power, and then we have here a pin for reverse power, and that will be a DC. So we generate finally a DC out of our transmitter signal. We keep the forward power and the reverse power, and we rectify it, and after the rectification we have a DC, and this DC is proportional to in our case our reflected power. And if of course our reflected power is too great, then of course we have a higher DC, and this DC will then trigger finally a little circuit which is able to protect our circuit. Yeah, and that is the little circuit. It is really nothing special. You will find circuits like this all over the internet. You need to search for it, so that is really easy. So you see here the input, that is the output to our low pass filter, right? And then we pick finally here our signal, so the forward and the reverse power, and we send it here through our rectifier. So that is the simplified explanation, and then you see reverse power and forward power, and that is of course of our diodes here. It is a DC, and thus we can use it for our protection circuit. Okay, but our SWR bridge is nothing without a protection circuit, and that is what we can see here. So that is simply an SCR based circuit. So basically that is very easy as well. So you can see here two inputs. So that are our inputs from our coupler, from our SWR bridge, if you like. And here, for instance, is our reverse input. And if the SWR is too high, so if you are transmitting into the wrong low pass filter, which will not then match with the transmitter frequency, of course, then the SWR might be high. In that case, you have a high DC voltage at our SWR coupler, and we will get this high DC or this higher DC, so we can adjust it. So you see we have here a potentiometer built in, and then we lead our DC directly to the SCR, and if we are getting over a certain point of voltage, then our SCR will switch through. And my configuration here is that then here this relay will switch, and when this relay is switching, we will have two things which happening. First of all, we get a red LED indicating at our front panel that there is an unwanted case, and secondly, and that is most important, we disconnect our TX-RX switch. So that means that our amplifier will simply get switched off, and then we have to reset our circuit. So we then set it to the right band with our manual band selector, and then we reset here our circuit. So we have here our reset switch, and after we have resetted it, it is then active again, and we can then transmit through our right low pass filter. And that is what we need to build. I mean, we have here already, as already said, our bridge, and now we need to build our little circuit, our protection circuit, which is able to disconnect our transmit and receive relay switch, or however you want to call it. Alright, and what you see here is our proto board planning. I put all the components on this little proto board, and I will follow here, of course, my little drawing. So for instance, here is my little relay, here is the SCR, and so that is what I need to build, and then we are almost ready for testing. So let me start and yeah, doing this little PCB that we can finally test it. Okay, and the little protection circuit is ready so far. Everything is here on our little proto board, and well, yeah, for testing I've installed here our LED, which is telling us that there is a fault, and that is what we get into our front plate, of course, of the amplifier. And this button here as well, so that is our reset button to reset here our protection circuit. Then I have here LED, but that is now only for testing, and will represent our amplifier when the amplifier is on transmit. So that will represent yeah, our amplifier, and that will not be any longer here in the circuit when we install it into our amplifier, as the amplifier has its own transmission indication. Alright, so now my unit is connected to voltage, and of course it is 13.8 volt, because that is the normal voltage which is valid for our circuit, especially for our amplifier, right? So that is our supply voltage, and the right power supply is which will simulate our arrow voltage. So if there is a high SWR, then we have seen from our SWR bridge that we get DC voltage, which will, in case of a high SWR, send a DC to our little board to, yeah, finally bring the unit here into arrow mode. Okay, so that is simulating, and on our board, yeah, here is our 13.6, here is our transmitter LED, arrow LED, reset button, and here is our input for our arrow voltage. Now it is already connected to 13.8 volt, and here this connector here, or this bridge, will represent when we bring here our circuit, or let me better say our amplifier, into transmit, because in that case we connect our amplifier and this little board, which is then in line with our transmit line in our amplifier. We connect it to ground, and our amplifier will go into transmit. So far so good. As long there is no high SWR, nothing will happen, and that is how this little circuit should work. But if there is, for any reason, a high SWR, we want this circuit to disconnect finally our transmission, and that is what our circuit is doing. Okay, so let me try to show it this way. So of course we have simulated that our transmitter is switched in, so our amplifier is working. And we said that this here will be our SWR DC voltage for reflected power. And well, now yeah, we have already 1.6 volt here at our error input. And now if we overcome a certain level, then of course our unit here, our protection unit, should switch off the amplifier. And of course we can finally adjust here the level where we want to bring here our unit in protection mode. So therefore that needs to be done when we have everything in circuit. Now for testing, I just want to know if our circuit is working or not. So if we are getting over an dedicated level, then of course our unit here, our amplifier, should switch off, not to damage something in our amplifier. And of course we get here, or we should get, our error indication. So let me simply increase here our error voltage. I mean, that is not how the SWR works, but for us it is nice to see that it works or not. And here we are. So you see at 2.4 volt input here into our error inputs, we see that our unit is noticing this arrow and is switching off our amplifier, and secondly is telling us, hey, it is switched off and we are in error and nothing will work until we release here our unit, our circuit, or with other words, we have to set our reset. But therefore, first I have to go down here, I don't know, to a level which is under our error level, and now I can reset here our voltage, and that might be then the case we have to adjust for the right band at our amplifier, right? And now I can reset it, and you see it is back transmitting, and we do not have our error any longer. And then once again, if we go, what was it, 2.4, you see it is directly switching off. And now when I try to release it, you see our error is there. So I have here my error input and I can't reset it. I have to take here my error information away, and now of course I can reset it, and my transmitter is working. So that is telling us that this little unit is working as we expected, and therefore we can go ahead in our project. Alright, and now I'm working here at our amplifier, and I've already taken out here this system connector, and I do not want to take it off. So maybe that in the future there might be an icon which still has this connector, and therefore why not let it in? And that is what I do. I just have taken it out that I will be able to bring here our wiring, yeah, that I can finally connect here our wiring for our amplifier internal switch, right, our band switch. And of course we know that our band switch will go here, because here we have already the hole, and somewhere here on my bench there should be the here it is. Here is our switch, and of course that will go down there. All right, and therefore I have now to produce here my wiring harness, and therefore I have to cut these wires. We need 7 which have to go over, because we have 6 different bend positions. You can see it here. 2 to 3, 3 to 5, 5 to 8, 8 to 13, 13 to 20, and 20 to 30. So that means we need 6 wires, and of course we need 1 ground wire, which we need to bring to the front plate, and that is what I'm going to do right now. Yeah, let me solder it here to our connector, and then we can take our next step. Okay, and you see I have here now my wire harness, which goes to the front, and yeah, this is the PTT line to switch our transmitter into transmit, and that is needed, of course, for yeah, to make the connection to the radio when the PTT get switched, that finally our transmitter here will transmit as well. Now let me bring back here this connector here into the back panel, and then I can start and yeah, putting here my harness over to the front. Our band switch is installed, and we have here now our wire harness. Our connector is back in, so everything is prepared so far. And yeah, you can see here the new wiring going to the front. And now what we have to do is we have, of course, to shorten here our wires, that we can solder them to our band switch, and that is of course our next step. So let me connect our wires to our band switch, and then we can go ahead. Okay, so we are ready for our first test. So you see everything is installed concerning our band switch. And I have already connected here our SWR bridge, and it goes here into our filter bank here, and on the other side I have here my mini vector analyzer, just to check if our filters are working, and if everything is just fine, and to see finally what are the SWR here on our filter bank. And therefore you see I have here a dummy load connected here to the output, and our amplifier itself is not connected. It is only set here to another dummy load, just in case that we do not get any damage here to our amplifier. We have over here our transmit relay, and to get our signal here out of our output, we need to get our transmit relay switched, and then we can use here our mini vector analyzer to analyze each of our low pass filter here in the bank. So therefore, yeah, let me do some preparations, and then we are directly back to see our graph. And first of all, we have to switch on our amplifier, And here I have now my band switch, and maybe you can hear that the relays are clicking when I switch it here. And now the second, what we have to do is to set our amplifier into transmit, and we have seen that this wire here is our PTT line, and I have to connect it to ground, and you hear the clicking, which is our transmitter relay, this one here, and that will finally switch our filter bank to the demi load. Alright, so now it is in transmit, and what you see as well, while it is set to transmit, we have here now our bias current, which we set in our last video to, I believe, 3.5 amps. So that is a required bias, and we can read it here on our amp meter. So we know everything now is prepared, and we can now check each of our low pass filters. Okay, and I believe we can see what we need to see, and I will sweep here from 1 megahertz to 40 megahertz, so that is the entire shortwave band. And first we will go through each of the filter over this wide range, and let me start the sweeping. My band switch is switched to position number 1, which is our 160 meter band, and let me sweep. Yeah, and what you already can see here is that we have here our lowest point, and it is at 1.78 megahertz. So you see that is here definitely our 160 meter band, and you see when we are leaving here our low pass filter, so where the frequency can pass through, you see that our SWR is increasing really strongly here. And yeah, that means we do not want to transmit, for instance, on the 20 meter band with a filter set to 160 meter, because we would then send into a high SWR, which we need to avoid. So that is what we are doing here. Now I go to our 3.5 megahertz range, which is our 80 meter band, and you can see it. Our lowest SWR is at 3.26 megahertz, so that is what we expect. The next is our 7 meter band, and but we have as well here our what is it, 60 meter I believe, and 40 meter is then over here. We will go through exactly on each band to see what really our lowest SWR is, but when I go now ahead, you see as more I go to the higher frequencies, once again we are talking about here it is a low pass filter. That means only the higher frequencies get cut off. The lower frequencies can pass through. So here even on 14 megahertz, wherever we are, so what is that here? That is a 10 meter, the 10 megahertz, so the 30 meter band, and you see that here at this point, so that is 10 megahertz, so you see our SWR is 1.04, right? And but even if we would send with the 80 meter into this filter, we would get here an SWR of, yeah, here we can check it at that point, 3.3 megahertz, so we are at 1.6. So sending into a low pass filter with lower frequency is not that harmful. It is always harmful if we would send here now with I don't know, with the 10 meter band into this, you would that would end up with a high SWR. So that is what it is all about. So when I go more into the higher frequencies, you see what that means. And that is here for 20 to 30 megahertz, so that is 15, 12 and 10 meter together over one filter, and that is what you can see here. So if we are leaving here the 30 megahertz, you see, maybe I can do it here also a bit bigger, and it might be easier to see. Yeah, let me go back to 13 to 20 megahertz, which is this graph, and then 8 to 13, which is this graph, 5 to 8, which is this, 3 to 5, and 160 meter band. So that is very clearly to see. When I now go here in to our bands, I can start here with the 160 meter band, and you see here the band edges M1 and M2, so that is what you can see here. And you see within this area, so within the band, so that is especially here for the European pass of our world, we see SWR 104, 103, so it is working just fine. When I go ahead here to 80 meter and we do the same exercise, and now I have to switch the band switch here. You see exactly the same 3.5 up to 3.8, which are the band edges again here in Europe. So you see our 3.8 is at 1.21 SWR, which is still nice. And we go ahead with the 60 meter band, and of course I have to where is here my M1 to M2, and you see we are our worst value is 1.54, which is still very nice. And again we go to the 40 meter band, and now of course I have to switch here my band switch, and you see here from 7 to 7.2 it is really 1.13, 1.11. it is working perfect. And we can go ahead to the 30 meter band, and of course I have to switch here my band switch once again, and you see here our entire band width is very good. It is SWR of 104, which is good. And now I go ahead, we go to 20 meter, and of course I have to switch it to the right position, which is here, and you see my SWR is dropping down and 108, so that is really good. And now our last band filter is working over, let me double check, no, here 18 megahertz, which is also in this area, but you see it is also very good, no problem. Now we go to the next step, which will be for 15, 12 and 10. So let me go to 15, and I have of course switch my filter, and you see for the 12 meter band, for the 15 meter band we are in, it is 135. When we go ahead to 12 meter, and again we have a nice SWR, so you can see it here, 1.12, and our 10 meter band we have exactly the same, so you see from here to there, and it is 1.13. So that is telling me that our filter bank is really working very nice. So we cover all frequencies mid low SWR, but once again, if I go back here to the entire shortwave band, then you see that when I like to send with a higher frequency from my radio into the 160 meter band, for instance, then it is, of course, here you can see it, we will have a high SWR, and that is what we need to avoid, and that is the reason why we built here our protection circuit, that when we transmit with a higher frequency from our radio into the wrong filter bank, into the wrong low pass filter, and the radio, or better said here our amplifier, is seeing a high SWR, then of course our protection circuit has to switch off our transmission. So that is what we are doing here. Okay, that means all is working fine, no problem. Now I have to do here some mechanical arrangements, and then we can go ahead. Okay, so as you can see, our bridge is in, so mechanical work is done, and over there we can observe what's getting out here of our power amplifier, and down here I have the driver, so radio sits on the 20 meter band, and my band selector here is connected to the 20 meter band, and I'm now interested in the question if our bridge is working. So therefore we only will feed in really a little power, really a little, just to see that the amplifier is working. So let me see if we can handle it here somehow. So once again, down here at our bridge we have two outputs. One is for forward power, and just to remember what we have done, our forward power will get converted into a DC voltage, and here on the left hand side is our connector for reverse power. Now I just set here our amplifier into transmit, therefore I put here my PTT to ground. Now it is ground, and you see here my power meter. Let's see if we can the lightning here a little bit better, I don't know. So now I'm interested when I put a little power here into my amplifier, which well, that is much too much. So let me go down to, I don't know, 25. So that is now the output from our power amplifier, and we are feeding in 3 watt into the power amplifier, which will give us 23 watt output. Now I want to see what is here the DC for our forward power, and you see it is 1.5, which is fine, and here our reverse power is 99 millivolts, so that is exactly what we really want to see. And now when I increase here my forward power, so let me increase it, you see that here my DC is really getting up to you see it here to 7 volt something. And on the other hand, of course, my reverse power will get up a little bit as well, 1 volt versus forward DC 6, which 250 watt output power. So let me bring it back here. Alright, so that now is of course telling us that our bridge is working fine, so that is exactly what we expect. We need to get here our DC voltages, and that is then the voltage which we want to feed here into our protection circuit. Now yeah, you see, so that is new. I have upgraded here my protection circuit with high quality potentiometers, so these potentiometers are sealed, so no dust and what have we, humidity can get in, so I thought that is really a good idea. But back here to our experiment. So once again I'm transmitting, you can't see here, so you can see it. Now we have 23 watt output, and with 23 watt output again 1.6 volt forward DC, and our reverse DC is 115 millivolt, right? What will be the case? So let me release here my output power. What will be the case if I do not transmit in the right low pass filter? So let me set here my band switch to the 160 meter band. So our radio is still on, you can see it here on a 20 meter, okay, and my band switch is maximum left, so that is position 1, which is now representing our 160 meter band. Now the important question is, what will happening if we start our transmission, and let me see, we had millivolt on the right filter setting, and let me see if I pick here now my reverse, and let me see what we get on reverse. 1.5 reverse, and that is more or less equal to the forward. Yeah, so you see our SWR bridge is working, and we get here on our reverse output a higher DC voltage, which is telling me, oh, here our band switch is wrong, so our power amplifier is seeing a high SWR. And in that case, under these circumstances, our protection circuit has to switch off here our transmitter, right? So that means our PTT line, which is now here, needs to get disconnected or interrupted to stop transmission into the wrong filter. So that is what it is all about. Okay, so next step is done. You see our protection circuit is in, and it is already connected. Of course, you can see that here our reset switch and the LED is still here on our little project board, and these both controls have to go into our front panel, that is for sure. And we have over there our, where is it, our PTT wire, alright, and there we need to do a connector here at the back panel to make the connection to our radio. Down there we have a new voltage regulator, which is finally supplying here our protection circuit. And here we see our PTT line coming in and going back then to the back panel for the PTT connector to the radio. So that is so far connected. Oh yeah, and here of course we have our arrow input, which is already connected here to our bridge over there. And yeah, that is ground here, nothing special. So basically that all is already connected, and we can perform our first test. Alright, so let's do our first test. First of all, I have to set here our amplifier into transmit, which I can do by setting here our PTT line to ground. Maybe you have heard the click. Now our bias current is present, and yeah, our radio is still, let me see if you can see that here, is still on the 20 meter band, so 14 megahertz. And let's see that everything is here done correctly. So our band switch is to 20 meter, so that is good. And now I press our PTT at our transceiver, and let's see. Yeah, so we do not want to put too much power in here for test purposes, but you see we are transmitting with 26 watt, and the input to the transceiver is, I don't know, a half watt or so, maybe a bit more, but not very much. Nah, not a half watt, that was wrong, 2 watt. It is 2 watt input, and that gives us 25 watt output, so very nice, no problem so far. Now I switch it off, and now we set here our filter to a wrong position. So that means in this case we want to see our protection circuit switching off our radio. So let's see how we can get it here into the the view, maybe that way. Here is our LED, and now let me transmit with our 20 meter band 14.100 megahertz into our 1.6 in our 160 meter band low pass filter. So let's see if our protection circuit is working. And wow, have you seen that? So here is our protection circuit, and it has directly switched off here our PTT line, so it can't transmit any longer, even if here our transceiver is working. And when you see now 2.8 watt, that is what is directly coming from the transceiver, passing here over the bypass filter to the antenna. So that is in reality our input power to our amplifier. But you see our amplifier is totally switched off, and that is what we want. So what we need to do, we need to switch off, of course, our transceiver. Now we can set it to reset. Okay, we go back to the right bandpass filter here over our band selector, and now when I press my PTT once again, you see that very easily I get here output power again. So that shows that our little circuit is really working just fine, exactly what we want. So the only thing what is left, we have to bring here our controls to the front panel and the PTT connected to the back panel, and then job is done. I mean, yeah, when we have it connected to the radio, where it will really go in operation, we need to adjust the controls to the given antenna at that point, and we need to adjust it a little bit to the radio, that it really works on all bands as it should. But you know, that is only a little fine trimming. Then basically we can say circuit is working, and that is exactly what we want. Okay, so front panel is so far ready. So you can see our band switch, our alert LED, and our reset. So that is now done. And yeah, our radio is set here again into the 20 meter band. And I try to do here a little more. Can we see? Not sure if we really can see the meter up there, but I hope. So okay, I'm on the 20 meter band, and when I'm now talking, so you see a peak over there, 556 watt PEP output, 1212, hola! So that is real 560, and you see everything is working just fine. We are here on the right band, and that means we are using the right low pass filter, and everything is working just fine, no problem. Okay, so now let me switch here the band filter to the 30 meter band, which is of course wrong. And that is what can happen in manual operation, so that you switch your band, your frequency on your radio, but you forget to adjust here the right filter. So that is now what we have. I'm still on the 20 meter band, filter is set to the 30 meter band, and now once again 1 2, and that is exactly what we want. So the radio goes directly into alert, telling us something is wrong. You see here that our BIOS is interrupted because our PTT line is interrupted, so you do not have any transmission any longer here over our PA. So now what you see over there is what is coming here from my radio, okay? So that is what we get from the radio. Now when I switch here back on reset, and when I now go back to the right filter, then 1 2 1 2 hola, 1 2 1 2 3 hola. So you see now it is definitely working as it should, and our alert does not come up. So you see how important it is to have this alert circuit, that you really know that you are on the wrong filter. I mean, as we are talking about low pass filter, when I switch here to the higher filter, then still the SWR will be low. So that is, you can do it like this, nothing happens, and that is normal because it is not a band pass filter, it is really a low pass filter, and everything below the 15 meter band will, or below the 10 meter band, sorry, will pass through, right? So I mean, that is in the nature of a low pass filter, but having this here on the right, on the wrong position does not jeopardize your amplifier. I mean, you might produce distortion on the air, but it does not do anything to your amplifier. So therefore you always need to have it if you're on the wrong filter. Now we are on the 8 meter filter, and 1 2, and exactly we are running into alert, and that is what we want. And now we can do it here once again, and it is working. So you see, everything is fine. Let us have back a look into our amplifier so that you see the final status. Okay, and here you see our little protection board, and everything is wired. So the only thing I have to do finally is to install here a connector for the PTT line. Still PTT is here switched via my cable here, so that is not how we need it. So therefore I will finally install here a PTT connector, which will then get connected to the radio what you're using, and then if you're pressing your PTT on your radio, then of course this PTT line will get grounded, and our amplifier will get into transmission mode. Alright, we are finally at the end of our little project. As I told you, I only have to install my connector, my PTT connector, that's it. But I think that is clear to anybody what we have to do here finally. Other than that, everything is done, and I think we should not extend the video any longer. I hope you have the idea. I hope you see how you can manage like these tasks, and yeah, thanks for watching, and catch you next time. Bye.